Good afternoon, ladies and gentlemen. It is my pleasure to be part of the NLP Summit 2022. My name is Gary Kazantsev. Thank you, David, for your introduction. I have been with Bloomberg for 15 years at this point. It's a little bit strange. I never expected to be here this long, but this place never ceases to amaze you. For most of that time, I had been engaged in building and leading the machine learning engineering group, now called AI Engineering. We were and continue to be responsible for most of the client-facing applications of machine learning and AI, both on the Bloomberg Terminal and enterprise product portfolio. Albeit the range of applications of AI and machine learning at this point at Bloomberg is quite large and transcends NLP. My today's talk on applications of NLP in finance is thus also a talk somewhat about our journey and my group's journey through the machine learning field as it was developing and growing over the last 15 years. A lot of what I'm going to talk about today is going to be in context of this visual. This is the real-time news feed as it comes into the Bloomberg infrastructure. When I started at Bloomberg in 2007, we were already routinely ingesting 250,000 stories per day. Today, we ingest over 2.5 million stories per day on a regular basis. From a talk by a professor at Columbia last year, I know that the total number of news stories published in the world is around 3 to 4 million stories per day. So we take in somewhere around 2/3 to 3/4 of all news written anywhere. We have an archive of this going back decades, which numbers in the billions of documents. It comes from hundreds of thousands of sources in over 40 different languages and encompasses an enormous range of content. Traditional journalism, social media, press releases, filings, research reports, earnings call transcripts, and so on and so forth. Sometimes people ask when they look at this screen, what does it mean when the story turns orange? And the answer is, that means it's old. I wish that was a joke, but it's not. It goes without saying that human beings cannot consume even a small fraction of this information. In a way, we're victims of our own success. People asked us for all the news in the world. We went out and obtained them. And then people said, well, we can't read this all. How do we make sense of all of this information? That question led us on an interesting journey. How do we build tools for people to make use and take advantage of this information without them having to consume all of this text? The same questions arise for other types of data: trades, codes, weather data, geospatial data, audio, video, credit card receipts, you name it. But we started our journey with news, and a lot of it was and continues to be focused on NLP. Our AI engineering group at this point numbers around 300 data scientists and machine learning engineers, most specialized in NLP domain. And many of the flagship applications of machine learning and AI for Bloomberg continue to be in the NLP space. Well, what kind of tools can we imagine? Certainly search is something that was already very familiar to people by the end of 1990s. And it was table stakes by mid-2000s. However, Google-style search doesn't really suffice for our domain. Our data has a lot of complex structure, and we need search that understands at least some of the semantics. What is this story about? Perhaps a company, perhaps a product, and maybe I'm an equity analyst in China. And I'm interested in what happened last week. And furthermore, I'm interested in what happened on social media. Now, I don't know of another system in the world that can do this. This shows a result of a whole lot of technology. To be able to do this, we first need to annotate all the incoming documents with metadata, with entities like companies and people, topics, geography, products, industries, and so on. And we need to do it across many different languages. And we need to do all of these things in real time, in milliseconds, 500 to 1,000 times a second. That's the peak volume of our newsfeed as it comes in. Almost all of this is done by machines. There are thousands of hybrid statistical models behind the scenes that read all of this text and attach these labels in a probabilistic manner. Then on the user side, we have to take in a string like this. Oops. And understand it in the sense of generating a semantic parse tree of it using a probabilistic context-free grammar and semantic rule labeling. Note that this query is ambiguous. We could be talking about different types of securities or documents, so the parser cannot disambiguate this query fully. And instead, the system has to synthesize the answer of sorts by stitching together different types of results from different backend systems. There's an additional ranking problem here, which is also a machine learning problem. This is great if you know what are you looking for, and it saves a lot of time to users and saves a lot of clicks even for expert users. You can do all kinds of things using this facility. Or, for example, so this is called question answer. And this is wonderful when you know what question to ask or what are you looking for. But suppose that all you know is that a particular instrument changed value and you're looking to explain why that happened. So this is a chart of Apple. This is 1 year's worth of last day's prices. And we are interested to know what happened here. So here we see the key news themes for Apple at that point in time. So this gives us a bird's eye view on what has been happening in the news stories about Apple on that day. Right? And you can modify this to go over a different time range or point it at a different point in time. If you want to look at the key news themes, you can go directly to this function and you will see the summary of sorts of all the news stories about a particular search or topic or company or whatever it is, right, over the time period that of your choosing. So all of these stories go through an online clustering system. Right? So in the last 24 hours, there have been several hundred stories about Apple. Of them, 25 fell into this cluster. These are some representative stories for that cluster, and this white part is a summary, which is an output of a neural network. All of these stories have to go through a fairly deep NLP pipeline to produce this result. And let me tell you, it took a lot of work to make a neural net to produce something which is as coherent, as readable as this. At this point, we're practically experts at the care and feeding of large neural networks. So this is more than just summarization, because this is really a type of synthesis. So all of these stories, besides being clustered, go through an information extraction pipeline that selects the keywords and phrases in each document. And then those keywords and phrases are ranked and fed into a sequence-to-sequence neural net that then synthesizes this white label or summary. We do synthesis in other places. So as you can see, every keystroke, the string that is offered as a suggestion changes. And this is a means of discovery. Historically, the Bloomberg terminal would expose things which are called mnemonics, kind of like shorthand to many thousands of different applications or functions that are available to Bloomberg terminal user. I have no idea how people use this system before autocomplete and query auto suggestion. And this facility of generating suggestions in a context-sensitive way improves the usability of the system a great deal. Essentially, what happens is at each keystroke, we are running the parser, the semantic parser that would take the string apart in reverse, essentially, and then filtering results for salience and ranking them to produce something which is going to be maximally coherent. There are other types of synthesis. So all of these stories on the screen have been generated by a machine. So this is a different type of synthesis, and here the story is identified as having been produced by a machine. Some of it is fairly straightforward template filling. Some of it is more complicated synthesis, which is done using constraint satisfaction. Now, back to news again. We know now what the stories are about. Companies, people, industries, products. What other questions can we ask? Well, we can ask whether the stories are positive or negative about a particular entity. So, for example, so here we see a chart of all the news stories about Apple as a time series in 30-minute intervals over the last couple of days. And on the bottom, we see a proportion of them which have been respectively positive or negative in the sentiment analysis sense. This is a very narrow and specialized version of sentiment analysis because it is grounded in market behavior. We are trying to anticipate essentially the opinion of a long position holder in the underlying instrument if they were to read the story about Apple in absence of other information. We spent a lot of time on this problem, and we continue to work on it. This is one of the first real applications of machine learning at Bloomberg, and we started working on this in 2008, 2009. At this point, I think we know pretty much everything there is to know about this problem, having solved it dozens of times for companies, for currencies, for commodities, in English, in Chinese, in Japanese, for news, for social media, etc., etc., etc. I could talk about this problem at length, but in the interests of time, I think I will instead mention a couple of other aspects of our work and maybe one or two other applications. As I mentioned, we have invested heavily in this area, and nowadays we routinely publish between 30 and 50 papers on NLP and machine learning applications of NLP in the top conferences such as EMNLP, AACL, NAACL, AAAI, and so on. Many of these are at the cutting edge and the forefront of the industry. So we publish in a range of different topics, and a lot of what we have been doing over the course of the past, call it 12 months, has to do with large language models. People have undoubtedly heard of things like BERT and various BERT variants and more recent versions of these models, large transformers like GPT class models and PathLM. And it is not a secret that we have built many of these models for a variety of different purposes. In fact, a lot of our NLP pipelines, and we have hundreds of them at this point, are built on top of these large transformer models or more classical sequence-to-sequence neural nets. For example, that function that I showed previously, the clustering engine underneath it uses a model which is called the neural variational document model to compute semantic representation of stories to find the appropriate clustering. You could do this right now using a transformer, but the model that we have chosen some years ago still gives us state-of-the-art results and is a lot faster in practice. That is one of the key constraints that we have in applications of machine learning and NLP. A lot of the things that we do have to be done in real time. One might ask then, what do we use something like GPT model for? And the answer is actually quite interesting. These models are extraordinarily good at few-shot or even zero-shot learning. And one of the ways that we and others had used them actually is for training data generation. One of the most interesting papers that we had published earlier this year was on using these models to generate paraphrases. Paraphrases are a key problem in natural language understanding. This is used for a variety of different downstream tasks, from question answering to summarization. And paraphrases are quite difficult to come up with in terms of training data by human input. Instead, what you can do is engineer the prompt and give this large language model a set of few examples, right, to prime it essentially, to tell it what task are you trying to solve. And by carefully tuning the prompt, you can generate suddenly hundreds of thousands of paraphrases based on the language that that model had absorbed, right, from being trained on something like Common Crawl, or in our case, on all the news stories that we have collected over the past 20 plus years. I could speak at length about other applications. A lot of them at this point are at the intersection of this large language models direction and things like synthesis and summarization, as I have alluded to in my presentation. But in the interests of time, I think I will wrap up, and I will be happy to answer your questions in the chat at the rest of the conference. Thank you very much and have a good day.